Astronomers have done it again. This, ladies and gentlemen, is the first image, the first direct visual evidence of Sagittarius A star, a supermassive black hole at the center of our Milky Way galaxy. It took a network of 8 radio observatories spread around the world, known as EHD, which stands for Event Horizon Telescope, and more than 300 researchers from 80 different institutes working rigorously for 5 years to make this possible. Now you may think that this image isn't particularly impressive and probably even too blurry, but believe me, it's a lot better than what we previously had. Sagittarius A star is located about 25,000 light years away from Earth, right at the center of our Milky Way galaxy, has approximately 4.3 million times the mass of our Sun, and actually you could fit 17 suns across its diameter. The image we can see here was created by combining thousands of images from the telescope observations. There were many features that appeared rather infrequently across all of the images, and for that reason, those features have been suppressed in favor of more commonly seen features. In this example, you can see the images clustered into 4 different groups, each one of them showing its own characteristic features. And thanks to the bar graphs at the bottom left of each cluster, we can see how many images belong to each group. Thousands of images fell into the first 3 clusters, and that is why the final image looks the way it does, with the event horizon right in the middle and hot glowing plasma falling around it as the huge gravity bends the light itself. This new breakthrough follows the well-known 2019 release of the first image of a black hole ever taken at the center of the more distant M87 galaxy, which was also released by the Event Horizon team. But even though both images look almost identical, there are many differences between the 2 black holes, which at first are not obvious to the naked eye. M87 is 1,000 times more massive than Sagittarius A, and it is a lot more active. The difference in size also becomes clearer if we pay attention to the speed at which objects orbit around it. Since M87 is 1,000 times bigger, it also takes much longer for the hot gas to orbit around it, usually taking days or weeks. This is a stark contrast to the mere minutes that the plasma around Sagittarius needs to complete its orbit. And this is exactly the reason why scientists needed to take so many images of the black hole. In contrast to the steadier target that M87 was, the rapidly changing patterns of gas around Sagittarius A star made it especially challenging for the team to come up with the final composed images. Another key difference between both black holes is how far away they are from us. M87 is not only 1,000 times bigger, but also nearly 2,000 times further away from us than Sagittarius A star. And this fact might make it look like it would have been easier to first look at the closer black hole in our own galaxy. But unfortunately, that isn't the case. You see, there's a lot of dust and gas between us and the center of our galaxy, making it impossible to see the black hole with visible light, thus needing to switch over to the infrared spectrum, which is what ultimately allowed astronomers, with the help of the telescope, to finally observe it from Earth after so many years of knowing that there was something there that couldn't be seen. Now that scientists have images of 2 different black holes in their hands, they will have the opportunity to further understand how they compare to each other. They have also begun to use the new data to test theories and models of how gas behaves around supermassive black holes, which is a process not yet fully understood and is believed to play a key role in the formation and evolution of galaxies. So there you go, a quick update on this massive event. I'm really happy to see the second ever image of a black hole, and I hope you're too. Thanks for watching. I will see you all in a new video very soon. Take care. Bye bye.